So in this lesson, I'm going to be talking about the process that's called electrolysis. Now, electrolysis is different from a voltaic cell simply because a voltaic cell the reaction occurs spontaneously without the need for outside energy. Electrolysis requires energy. So here are two diagrams right here which show you what happens in electrolysis. Notice it's almost identical to a voltaic cell, except you need some sort of voltage source for electrolysis to occur. Well, the question is, if there's only that difference, why do we really care? Well, it brings up a couple of concepts that we need to talk about. The first one is a qualitative one. If you've ever bought a piece of jewelry, in all likelihood, it's been coated with a metal. And so electrolysis is how that piece of jewelry was coated. What happens, as you can see on the right-hand side, if you start with a nickel anode, right, nickel solid, and then you have a ring that's just made out of whatever metal, what you can do is actually have that nickel become nickel ions by oxidizing it. And then if you run a power source through that, what that can do is actually cause the nickel ions to then be reduced and actually cause solid nickel to coat a piece of jewelry. And so that's what they do. It's called electroplating. That's what they do in order to coat your jewelry. So the reason why for a voltaic cell, why you need two different elements is because in a voltaic cell, that happens spontaneously, so you need different cell potentials. But if you're going to provide the energy, you can actually take a solid and put it onto another object by first making it into an ion and then reducing it so it goes from being an ion in solution back to being a solid. So there's actually some math that's incorporated with it. The first concept that's new is Faraday's constant. What Faraday's constant is, it simply tells you that there are 96,485 coulombs of charge per mole of electron. And so we're going to be using that in just 1 second. The other piece of information you need to know is about amps. Now an amp is a measure of current, and that simply is 1 coulomb, which is a unit of charge, per second. So we can use those two pieces of information to answer this question right here. What it says is it asks you to calculate the number of grams of aluminum produced in 1 hour by the electrolysis of molten aluminum chloride if the electrical current is 10 amps. Well, the first thing I need to do is figure out the reaction that's occurring, what exactly is going on. Well, if I start with molten aluminum chloride, that means I have aluminum ion. So I've got Al3+, okay? And that's going to produce solid aluminum. Now, the other piece of information you need to know, because this is a reduction reaction, meaning I am gaining electrons, then I'm going to have 3 electrons on my reactant side. So that's key when we use Faraday's constant in just 1 second. So I'm going to start off with my given, which is 10 amps. Well, 10 amps is the same thing as saying 10 coulombs per second. And so what I can do is actually solve first for the number of coulombs, the charge that's involved with 10 amps. So I can do that because the electrolysis takes 1 hour, which is the same thing as 3,600 seconds. And so I'm now in coulombs because my seconds canceled. And what I can actually do is I can get into moles of electrons by putting the Faraday's constant of coulombs on bottom and 1 mole of electrons up top. The next thing that I need to do, though, is I need to get into moles of just aluminum because I want to know how much aluminum I'm producing. Well, the reason why I wrote that reduction reaction above is because I know that 1 mole of aluminum is going to be produced for every 3 moles of electrons. And so I can use that conversion factor right there, put 3 moles of electrons on bottom, 1 mole of aluminum up top, and then I can get into grams by simply using my molar mass. And so when I do all of that out, I end up finding that I'm going to produce a total of 3.36 grams of aluminum solid by this electrolysis reaction.